Welcome to the Sophistic Online documentation. In this part of our composite bridge tutorial, we show how to define the loads on the bridge. We will directly start in our graphical preprocessor Sophie Plus and define the loads. First step, we will go to the load case manager and first define the actions on the bridge. These actions will be used later on in the superpositioning and the creation of design combinations. So as you can see, we already have some actions available, among them creep and shrinkage, dead load, pre-stressing, and temperature. Now we will create some further actions. So I will create, for example, an action for settlement, load cases, and of course we also need actions for the traffic loads. So here I create action for live loads of category T, which will be used for the axle loads of the tandem system and the corresponding results, and for the area loads of the traffic load model LM1, so the UDL loads, I will also create further action of category U. Okay, and with that we can start now and create load cases. First, I will create a load case, number 1, which will be used for the additional dead load in the construction process. So I name it like that. I will assign the action none because these load cases will just be used to carry the loads and refer it later to the construction stage manager when we calculate the construction process. Okay, then we can create the loads. First, I will create the loads for the asphalt layer using elements loads on the structural areas. For this purpose, I select all the structural areas and create the load. You can see the assigned load case is already the correct one. Yeah, I want to have a load and one acting in gravity direction. And here I will use an area load of 2.5 kilonewton per square meter. Okay, you can see that the loads have been created and are associated with the area. Also in this load case 1, I will put line loads at each side of the bridge, which basically represent the safety barrier and the corresponding concrete part at the bridge edges. So load case is okay, load is okay, also the type, and even the value is already okay. So then I choose the start and end point, and same on the other side, and then I have my additional dead loads defined. Next, we will define the settlements. So for that, I go back to the load case manager and first create the load cases. I would like to give it a different number. Therefore, I delete it, deselect the automatic increment for the load case number and create it once again. And I will use here load case 51. Call it settlement. Now I will also assign the action because this load case really need to be taken into the superposition later on. And so this would be the load case for the settlement at the first support here at the abutment. And of course I need two further ones, one at the inner support and one at the second abutment. So I select the increment and create two further load cases. Okay, then let's create the loads. This will now be point loads. And I select the corresponding structural points, select the correct load case. The load type should be displacement in global Z, and I choose a value of minus 20 millimeters because, as you can see, our global Z direction is pointing upwards. Okay, then same at unit support. Now this of course has to be load or displacement rather at the bottom of the pier, and then once again same game at second abutment. Okay, now let's define the temperature loads. First, I will create the corresponding load cases. So I create a new load case with number 81, and I will name this DTN plus, which should take the constant temperature load leading to an extension of the bridge. Then I will create next load case, TN minus, for constant temperature leading to a contraction, and then load cases for the linear temperature distribution over the cross-section height, which I will call DTM plus, so acting like a positive moment, which basically means the bottom of the section is warmer, and next load case DTM minus, acting like a negative moment, meaning the bottom is cooler than the top. Here I also assigned no action because we will later on combine these temperature load cases as prescribed by the Eurocode, and then these combined load cases will get an action that will be later on used in superpositioning of the design combinations. Okay, now we create the loads. So, okay, I will start with the area elements and show you in further option to define the loads. So, for example, I can select the structural areas, then go to loads, and as you see, I already get displayed the loads that are defined on the structural areas. For example, the additional dead load that we defined previously, and I also can now define loads here. So I will add two loads. So the first one for the load case 81 extension, and then one for 82 contraction. These are temperature loads and basically a temperature difference extending in local X and Y direction. So for the extension, I will set the value of plus 31 degree, and for the contraction minus 30 degree, and click on OK. And as you can see, these loads are now created on the selected area elements. So I will repeat this for the structural lines. So main girders and the transverse bracing. So I select all the relevant line elements. Make sure to get all of them. Okay, and as previously, now I can directly create the loads. So here I will first create the temperature loads for extension and contraction as previously, because these are relevant for all selected structural lines now, also for the transverse bracing. So, okay, we have temperature difference, which means constant distribution over the height, and we set the corresponding values. Okay, you can see the loads have been created. Still missing are the loads for the linear temperature distribution over the section height. So this is something that is here only relevant for the main girders. So I will only select those. Okay, you can see what we already defined on these lines. I will add two further entries. So here one for bottom warmer than top and the other for top warmer than bottom. Type is once again temperature. Now temperature difference in local set. Now we have to think a bit more about the correct sign. So positive value means the section gets warmer in positive local set, and local set is pointing downwards. So for this load case where the bottom is warmer, we have to set a positive value. Here I will set 18 degree, and for load case 84 the other way around, I will set -15. Okay. Now we can export from Sophie Plus and then use graphic to check if we have defined everything correctly. Load case 1, the additional dead load, looks fine. Settlement here, here, we'll scale the size a bit up here. Here is also fine. Temperature +31, the slab, and in the beams. Same for the contraction, so -30 degree. And then we have a linear temperature distribution of +18 at the main girders, and then -15 for next load case. Okay, so what is still missing now is the pre-combination of the temperature loads. Eurocode suggests to investigate load combinations of the temperature, where the part for the temperature distribution varying over the height is combined with the part for the constant temperature distribution, thereby applying a combination factor on either the varying or the constant part. To do this, we go back to the Sophistic Structural desktop and insert a new task for the combination of characteristic loads. Double click on it. Now we can create the combinations. So I will create the first one. So I will give a number for the newly created load case that carries the combined loads. So here I give number 91, for example, then assign an action. So now action T for the temperature. I can give a title. So here I would like to combine the constant part with the varying part over the height using the combination factor on the varying part. So here 0.75 DTN plus the full DTN load case. And of course, I have to add the two load cases. And assign the correct factors. This we will repeat for all the combinations and create the 8 possible load combinations. Okay, then we create the combinations. Now we have all the relevant loads defined and can go to the analysis, which I will present in the next video.